Hi, welcome to Plain Techniques. I am not against extra classes, but not everyone can afford them. If you cannot afford a tutor, this video is for you. Trig identities frustrate so many students, but they don't have to. I'll guide you through them step by step so you actually get it. Let's make maths intuitive. Trig identities confuse students because the basics are not clear. Many end up memorizing instead of truly understanding. If you're struggling, I've got grade 10 videos that break down the fundamentals. Watch those first, then come back here. By the end of this video, you won't just memorize identities, you will actually understand them. Alright, in this video, we are going to talk about trig identities. Number 1, we have sin² theta plus cos² theta equals to 1. Second one, tan theta will be equals to sin theta divided by cos theta. Right, now the main objective for these two trig identities is to make sure that you simplify trigonometric expressions. Alright, so we know two identities. Now we need a proof, right? That the first identity, which is sin² theta plus cos² theta, is equals to 1. Okay, now when you look at this, what we have is the left hand side and the right hand side. Okay, to help us prove that sin² theta plus cos² theta is equals to 1, we need to make use of a diagram. Right, now on that diagram, what we have a right angled triangle and we have our angle theta, r, y and x. Very important to understand that this is our adjacent and this is opposite and this is our hypotenuse. Okay, and the reason for that is because the angle of interest is directly opposite. That is why we call it opposite. It's directly opposite to that side, and this will be our adjacent. Obviously, that the longest side of the triangle will be our hypotenuse. We have the left hand side, okay, which is sin² theta plus cos² theta. Okay, now looking at the diagram that we have here, right, what is sin theta? Okay, so sin theta is opposite over hypotenuse. Let's go ahead and write that. So sin is opposite over hypotenuse squared plus what is cos? Cos is adjacent over hypotenuse squared. All right, now when you look at the diagram, what is our opposite? Opposite is y, and what is our hypotenuse? Hypotenuse is r. I'm going to go ahead and write those. So it's y and r, okay, squared plus. Now what is adjacent? Adjacent is x and hypotenuse is r. Now I'm going to go ahead and write x r squared. Okay, now when you simplify this, right, what do you get? Get y² r squared. So this side you have x² and r². x² r². When you look at this, right, the denominators are the same. Right, when the denominators are the same, what you do? You keep one denominator like so, r², and you add the numerator. So you add the numerator. So I'm going to start with y squared plus x squared. Y squared plus x squared. Okay, so now what you can do is rearrange these two, right? So I'm going to put something right here. When you have 1 plus 2, right? This is the same as 2 plus 1. You understand? So what I'm going to do is to rearrange this to start with x squared. Okay, so I have x squared plus y squared, which is equals to r squared. Now I'm going to call this my equation number 1. Now we need to make use of Pythagoras theorem. Pythagoras theorem. Right? So making use of our diagram right here, right? What is the rule or the theorem for Pythagoras? Hypotenuse squared is equals to x squared plus y squared. Okay, now what do I have? R squared is equals to x squared plus y squared. This will be my equation number 2. Now what I need to do is I have equation number 1 and I have equation number 2. Right, look at this. When you look at this, right, this is x squared plus y squared, right? What do we have here? We have x squared plus y squared. What it means is x squared plus y squared is equals to r squared, right? So meaning that in place of x squared plus y squared, I can put r squared, because x squared plus y squared is equals to r squared. Okay, now what I'm going to do is I'm going to say substitute equation number 2, which is this one right here, right, into equation number 1. This is equation number 1, right? So where I see x squared plus y squared for equation number 1, I'm going to put r squared. Okay, so I'm going to go ahead and put equation number 1 is x squared plus y squared over r squared. What do I have? In place of x squared plus y squared, I'm going to put r squared. Okay, r squared over r squared. What is r squared over r squared? Is equals to 1. Now, what do we have? We know that the left hand side is also equals to the right hand side. Okay, now we need a proof, right? Proof that the second identity, which is tan theta, is equals to sin theta divided by cos theta. All right, now this will be our left hand side and this will be our right hand side. Okay, now to help us explain, we need to make use of a diagram, which is a right angled triangle. What do we have? We know that this will be our angle theta. This is our hypotenuse, opposite and adjacent. So I'm going to go ahead and write those. So this will be adjacent, this will be our opposite, and this will be hypotenuse. All right, now I need to prove that this side, the right hand side, is equals to the left hand side. Okay, so I'm going to take the right hand side, which is sin theta divided by cos theta. Now the first thing that I'm going to do is write sin theta and write divide like this, cos theta. Okay, what do we know from the diagram? We know that sin theta is opposite over hypotenuse, so it's y divided by r. Okay, so that is y divided by r. Now we have divide. What is cos? Cos from the diagram is adjacent over hypotenuse, which is x divided by r. I'm going to go ahead and write that. X divided by r. Okay, now y over r, when I change this to a multiplication, okay, this is what you need to know. When I change it to a multiplication, this fraction will flip, meaning that r will be our numerator and x will be our denominator. This is what I mean by that. R will be our numerator, x will be our denominator. All right, now r will cancel r and we'll only be left with y over x. So the answer here will be y over x. When you look at our diagram here, right, y is opposite. Okay, so y will be opposite, and what is x? X is adjacent, right? What do you recognize? You can see that opposite over adjacent is tan, right? Therefore, we know that this is tan theta. So we managed to prove that right hand side, right, which is sin theta divided by cos theta is equals to tan theta. All right, so before we continue, I want to explain two things. Number one, Pythagorean identities. Okay, now we know that the identity, the first identity is sin squared theta plus cos squared theta, which is equals to 1. Okay, now a Pythagorean identity, right? The first one will be 1. The first Pythagorean identity will be what we do is we take sin squared theta to the other side. That is the first Pythagorean identity. What will be left with on the left hand side will be cos squared theta, and on the other side we'll have 1 minus. That one will change sign here and will be minus squared, sin squared theta. Okay, so the first Pythagorean identity will be cos squared theta, which is equals to 1 minus sin squared theta. This is the first one. Now the second one will be, we need to take cos squared theta to the other side. Now we'll be left with sin squared theta on the left hand side, and the rest will be on the right hand side. Okay, what do we have? We will be left with sin squared theta, which is 1 minus cos squared theta. This is what you need to remember, right? Meaning that when you see 1 minus sin squared theta, you can replace it with cos squared theta as you solve your trigonometric expressions. All right, let me give you some tips, right? So these tips will help you when you are faced with an identity expression, right? Look for tan, right? When you see tan theta or tan whatever, replace it with sin theta over cos theta. That is the first one. All right, now the second one, let's say you see 1 over tan theta, right? So this is the reciprocal, right? Meaning that you just flip this. So we know what tan theta is, right? Now 1 over tan theta will be cos theta divided by sin theta. Okay, so that will be cos theta divided by sin theta. All right, now the other one, right? You need to look for the lowest common denominator. All right, so what do I mean by that? Let's say you have 1 over 2 plus 1 over 3, right? What is the LCD? LCD, lowest common denominator. What we need to do right there is you say cross multiply. This is what I mean, cross multiply, right? And multiply here. So what I'll do is I'll take 1 and multiply it by that denominator. All right, now this is what I mean. 1 multiplied by 3 and then plus that plus right there, okay? And take 1 and multiply by this denominator, okay? So 1 multiply it by that other denominator and put a big division sign, right? And what you need to do is to multiply these denominators, okay? So 2 multiply by 3 and then simplify. So when you simplify, this will be 3 plus 2 over 6. Therefore, this is 5 over 6. All right. So this is the lowest common denominator. You understand that part? Always strive to find the lowest common denominator when you are given an identity expression. All right. Now, the last one is to simplify, right? You need to simplify where possible, where applicable, okay? You need to simplify or factorize. Example number 1. Express tan theta plus cos theta divided by 1 plus sin theta as a single trig ratio, right? How many trig ratios do we have? We have 1, 2, 3, right? We want to express this expression as a single trig ratio, meaning that we only need to have one of these, right? Either sine or cos or tan, right? So we can only have one of these, right? Not all of them or more than one. All right, now let's see how we go about it. The first thing that we need to do is we have tan here, right? When you have tan, remember you need to express it as sine over cos, right? That is the first thing that I'm going to do. So I have tan, I'll express it as sine theta divided by cos theta, and I'll write the rest of my expression. Cos theta divided by 1 plus sine theta. Right? Great. Now, if you have something like this, right, what you need to do is you need to cross multiply, right? When you cross multiply, you aim to get LCD, lowest common denominator, right? So this is what I mean by cross multiply. So sine will multiply that denominator, and cos will multiply this denominator, and the denominators will multiply each other to get the lowest common denominator, right? Let's put that into practice. Okay, so what I'll do is I'll put sine theta, which is this one right here, right? And multiply it by 1 plus sin theta. All right, so I'm going to multiply it by 1 plus sin theta. Now, what do? I'm going to put that plus right here, okay? Do I have? I have plus, and I'm going to take cos theta and multiply it by cos theta, right? So let's do that. Cos theta multiplied by cos theta divide by, now for the LCD, lowest common denominator, I need to multiply these two denominators, right? So that will be cos theta and multiplied by 1 plus sin theta. So I'll have cos theta multiplied by 1 plus sin theta. Okay? Now, what I'm going to do right now is to simplify. I'm going to multiply sin theta into all this, right? So sin theta will multiply 1 and sin theta will multiply sin theta, right? And cos will multiply cos, right? So the first one will be sin theta, because sin theta is multiplied by 1. So anything multiplied by 1 is that thing, right? Now, sin theta to multiply sin theta, we'll have plus sin theta squared, right? Now, the next one is cos theta multiplied by cos theta is cos squared theta. All right. Cos theta 1 plus sin theta. Now, I want you to look at something. This is what we have right here. Okay? This is what we have right here. What is this? This is a trig identity, right? Which is equals to 1. All right. Now, what am I going to do? I am going to replace, right, sin squared theta plus cos squared theta with 1, right? Remember, the main objective of trig identities is to simplify the trigonometric expression. So this is a way to simplify. When you see this, just simplify it or replace it by 1. All right. Now, I'm going to go ahead and rewrite my expression as sin theta plus 1, right? So the whole expression sin squared theta plus cos squared theta has been replaced by 1. Okay, I'm going to put the division sign. Then I write cos theta 1 plus sin theta. All right, great. So what I'm going to do is I need to remove these things so that I can create space. Now, let's continue, right? I am going to rewrite sin theta plus 1 as 1 plus sin theta, right? Why? Look at this. So if you have 1 plus 2, this is the same as 2 plus 1. When you add, right, it does not matter which one you start with, right? Because 1 plus 2, it still equals to 3, and then 2 plus 1, it still equals to 3. So it doesn't matter the order that you start with. Now, I am going to rewrite this as 1 plus sin theta. So this will be 1 plus sin theta divided by cos theta 1 plus sin theta. Okay? Now, look at this. What do you have? You have 1 plus sin theta, right? Which can cancel 1 plus sin theta this side, right? So these two will cancel each other. And I'll only be left with 1 over cos theta. Okay? So this will be my answer. All right. Example number 2. Express sin theta divided by tan theta as a single trigonometric ratio. Remember, it must be in a form of either one of these: sin theta, cos theta, or tan theta, right? Yes. Now, it mustn't contain two of these trigonometric ratios, just one trigonometric ratio. Right. Now, what do we have? We have tan. Remember, when you have tan, you need to rewrite tan as sine over cos. Okay, so what I will do is I'll put sine here, sine theta divided by tan theta. Okay, now sine theta divided by, now what do we have? Tan theta can be written as sine theta divided by cos. Okay, now I'll rewrite sine theta. When you change this sign, divide to multiplication, alright, what you also need to do is you need to flip the fraction, meaning cos theta will be in the numerator and sine theta in the denominator. Cos theta divided by sine theta. Right, what do we have? We know that sine theta will cancel sine theta and we will only be left with what? Cos theta. This is our answer. Example number 3. Example number 3 reads, determine the value of sine theta plus cos theta squared minus 2 sine theta cos theta. Right? Very important to note that this right here is the same as x plus y squared. Let's say x is sine theta, cos is y, right? How would you go about this? Very easy, right? What you say is x squared plus 2xy plus y squared. This is how you'd go about this expression, right? Nothing different right here. So you do exactly this, right? So it will be, I'm going to say sine squared theta, right? Plus 2 sine theta cos theta plus cos squared theta, right? Then what do you have? 2 minus 2 sine cos theta. Okay, now let's continue. What do we have? We have sine squared, right? And then what else do we have? We have cos squared. All right, I'm going to group them together. Okay, so I'm going to group these two together. Sine squared theta plus cos squared theta. I grouped this one and this one, right? And I'm going to rewrite the rest of the expression. So this will be 2 sine theta cos theta, right, minus 2 sine theta cos theta. Right, when you look at this, right, this is the same as positive 2x y minus 2x y. So the answer is 0, right? So these cancel each other. So this is 0, all right? So I'm not going to write it. It's 0. What are we left with? We are left with that. I'm going to write it as sine squared theta plus cos squared theta. Now, what is this? This is a trigonometric identity, right? Which means it's equals to 1. Now the answer will be 1. Now that you understand trig identities step by step, you don't have to waste hours being confused anymore. Practice a few problems and you will see how much easier it gets. Let me know in the comment sections which part helped you the most or what you still need clarity on. If this video helped you, consider subscribing. I'm here to make maths intuitive. Keep learning, keep growing, and I'll see you in the next one.